Hi there, in the last video I went through this result. So this result enables you to work out the scalar product equation of the plane. So the scalar product equation, remember, was r dot n equals capital P, so where capital P is a dot n. N is the normal vector of the plane, and small a, that vector is the position vector of a fixed point on your plane. Okay, so let's try some examples here. So, example number one. So let me take a ruler, red pen, underline that. So the question being, let's find the equation of a plane where, so let's do a couple of parts. So in part A, the position vector of a fixed point, A, that is given by I minus j plus 2k, and the normal vector n of the plane, that is given by 2i plus 4j minus k. Okay, so let me show you how this formula is applied. So this is the scalar product equation for the equation of the plane, r dot n equals capital P is a dot n. Okay, so let me show you how this result is applied. So first of all, what I would do is, in step number one, I'd work out capital P. Okay, so capital P is a dot n. So a is I minus j plus 2k. Taking a scalar product of that with the normal vector 2i plus 4j minus k. Okay, so remember, when we take the scalar product, we just multiply the coefficients of the I, j and k components, then we add. Okay, so if we multiply the I coefficients, we'll have 1 from here, multiplied by the coefficient 2 from the second vector, plus, if we multiply the j coefficients, minus 1 times 4, plus multiplying the k coefficients 2 times minus 1. So if we simplify, 1 times 2 is 2, minus 1 times 4, minus 4, 2 into minus 1, minus 2. So the scalar P is minus 4. Okay, so that completes step number one. Step number one, work out capital P, that is a dot n. And in the last step, step number two, substitute your results into the formula. So the equation of the plane, formula as we've seen, r dot n is equal to capital P. So it's going to be r dot, the normal vector that is given, 2i plus 4j minus k. That is equal to capital P in step one, that was minus 4. Okay, so that is the equation of the plane in, as we say, in scalar product form. Okay, so those are the steps in order to work out the equation of the plane in scalar product form, given the position vector A of a fixed point on your plane and given the normal vector of that plane. Let's try another one. So a part B. If A, the position vector of the fixed point, is 2i minus j plus k, and if n, the normal vector for the plane, if that is I plus 2j minus k. So, same question, let's work out the equation of the plane. So, in step number one, let's calculate P. So, P is a dot n. So, a, that is given by 2i minus j plus k, dot with normal vector I plus 2j minus k. Okay, so remember, when calculating the scalar product, multiply the coefficients, then add. So if I multiply the I coefficients, 2 into 1, plus multiplying the j coefficients, minus 1 into 2, plus multiplying the k coefficients, 1 into minus 1. Okay, so if we simplify further, 2 into 1 is 2, minus 1 into 2, minus 2, 1 into minus 1, minus 1. The scalar p will then be minus 1. Okay, so that is step number 1. Step number 1, remember, work out p. P is a dot n. And in step number 2, substitute your results into the formula for the equation of the plane. So the equation of the plane in scalar product form, r dot n equals capital P. And when we replace the results, we'll get r dot the normal vector I plus 2j minus k, and that is equal to the scalar that we found in step 1 minus 1. So that is the solution for part B. Okay, so that completes that example, and that also completes the video. So I hope you found this video helpful. Do related questions, and I hope to see you in the next video. Thank you.